Today we are going to see selection sort. Like in the data structure, we have already covered some other sorting algorithms like bubble sort, insertion sort, and then quick sort, merge sort. Today we are going to see one sorting algorithm, that is the selection sort, and how we will see implementation part in the Python, and after that we will see the heap sort, and heap sort is also a type of selection sort. Okay. Hello everyone, this is Sharda from GoEduHub Technologies, and can you please confirm me, am I audible, clear and loud, so that we can start the session? Okay. So first thing comes to mind is, what is the selection sort and how does this works? You know the other algorithms in the data structures, other sorting algorithms. Okay, selection sort is very simple sorting algorithm. This is the comparison based sorting algorithm. And this is in place, there is no need of extra memory. Okay, main idea behind this algorithm is pretty simple. We divide the array into two parts. One is the sorted and another one is unsorted. Let me open the paint. Okay, and here you can see the selection sort. Okay, in the selection sort we will have two arrays. One is the sorted and another part is unsorted. The left part is sorted and the right part is unsorted. Okay, initially sorted subarray is empty and unsorted array is complete given array. Whatever the data you are having, that is a unsorted array. So initially you can say sorted array is empty. Guys, can you please confirm me, am I audible or not? Okay. So what we are going to do here we are going to follow certain steps. Okay, we apply these steps in unsorted array. Like initially whatever you have in the form of array or a list, that is an unsorted array. And we apply these steps until our unsorted array becomes empty. Okay. First thing is, we will pick the minimum element from unsorted element array. Pick min element from unsorted array. Okay. Next step is, we will swap this with the leftmost element of unsorted array. Swap with leftmost. Okay, and now this, after the swapping, this leftmost element become a member of sorted array. And now this will not be a member of unsorted array. So this leftmost becomes a member of sorted array. Okay? And we apply these steps until our complete array becomes empty. Complete unsorted array becomes empty. Okay, are you getting the concept? So here we will take an example. I'll take an example of a list. These are the steps. Okay, I'll open the new file. Okay, and here I'll take a list. Suppose I'm taking a list of 5, 2, 6, 7, and then you can say 2, then 1, and then 0, and then 3. This is my initial array, or you can say this is unsorted array. Okay, this is our initial array we are having, and initially our array is unsorted array. So initially you can say sorted array is empty. Okay. Here the leftmost element. What is the leftmost element? This element. Index, you know that 0, 1, 2, 3, 4, 5, 6 and 7. We having 8 elements in our array. So leftmost element is, this is AR. So AR of 0. Okay. And this is leftmost, and remaining part is this array. So from this remaining part we will pick the min element. Okay. So here the minimum element, you can see minimum element is A of 6. This one. This one is minimum element. So array of 6. AR of 6 is 0 and this is 5. So what we will do, we will swap 5 and 0. We will swap 5 with the 0. Okay. So here 0 and then 2, then 6, 7, 2, 1, 5 and 3. Now this is my new array. And this new array is divided into 2 parts. This part is unsorted array and this part is sorted array. Sorted array having now 1 element and unsorted array having 7 elements. Okay, same thing we will apply with the unsorted array. We will pick the first element, leftmost element. Leftmost element is this 2. Okay, and from this remaining array we will pick the minimum element. Okay, minimum element is 1. This one. So we will compare this leftmost element and minimum element. Minimum element is less than this leftmost element, so we will swap them. So here this 1, this 2 replaced by 1 and this 1 replaced by 2. And now this 1 becomes the member of sorted array. So now my sorted array becomes 0 and then 1. And this unsorted array, you can call it like here 6, 7, 2, 2, 5 and 3. Okay. Now the leftmost element is 6. Leftmost element is 6 and from remaining array the minimum element is 2. So we will compare 6 and 2 and swap 6 and 2. So here in place of 6, 2 and in place of 2, 6, and this 2 becomes the part of sorted array. So 0, 1 and 2. This is sorted array. Okay, and then remaining array is 7, 6, 2, 5 and 3. Same thing we will apply with this. Like here we will compare 7 and minimum element from this. Minimum element is 2. So we swap 2 and 7. So here the 2 and here the 7. Okay, and this 2 becomes the member of sorted array. Okay, and new array is like 6 and then 7 and then 5 and then 3. Similar thing will happen with the 6 and minimum element from this array is 3. So 6 and 3 we will swap. So 3 becomes member of this sorted array. And remaining is 7, 5 and 6. and this is leftmost element, and out of this we will pick the minimum element, that is the 5. 5 we will swap with the 7. So 5 and remaining array is 7 and 6, and this 5 becomes the member of sorted array. So 0, 1, 2, 2, 3, 5, this is sorted array. And then out of 7 and 6, we will compare 7 and 6, swap them, and 6 becomes the member of this sorted array, 7 remaining, and at the end, 7 becomes the member of this sorted array. Okay, the final output is this one, 0, 1, 2, 2, 3, 5, 6, 7. Okay. This is called the selection sort. In the selection sort, what we have done, we applied the 2 steps. Like, we divide the array into 2 parts, sorted array and unsorted array, and initially sorted array is empty and unsorted array is complete array, right? And from unsorted array, we will pick the leftmost element, and then from the remaining elements, we find the minimum element, and then minimum element we will compare with the leftmost element, and we swap the leftmost and minimum element. Okay? Got it, the concept? Now I'll tell you how we can write the pseudocode, or how we can write the code for the selection sort. We can write the Python code for the selection sort. Okay? So let me open the article here and write a program to implement the selection sort. So here you can see selection sort is a sorting algorithm in which the array is divided into 2 parts, sorted and unsorted. We need to find out the minimum element from the unsorted array and put it in a sorted array sequence. Okay? So basically the algorithm is set the minimum element to index 0, and then you can say search the minimum element in the array, swap the value at the minimum index, and then increment the minimum index to point to the next element, and repeat these steps until our list is completed. Okay. Again you can see this one more example, 86, 45, 6, 32 and 5. Here initial element is 86. Okay, 86 we will swap with the minimum element, that is the 5. So 86 and 5 we will swap, and then from the 45 and 6 we will swap. Like this we will perform all the steps. At the end we will get the array 5, 6, 32, 45 and 86. Okay, for this we have to write a program. So let me open the Google Colab and I'll explain you how we can write the code. Are you getting the things, guys? Can you please confirm me in the chat window? Okay, let me open the new notebook, and here I'll write the code for the selection sort. Okay. So here I'll define a function, selection sort. Okay. I'll define a function def selection underscore sort. Okay. And inside this I'm passing my array that I want to sort. Then I have to compute the size of the array, that is the size equals to, length of this array. Okay. And then I'll write here one loop that will run from 0th index to size minus 1. Like I'll traverse this complete array. Okay. So here I'll write one loop. For I in range, okay, size minus 1. I'm traversing complete array. Okay, and inside this what I have to do? Okay, basically this I index is total number of elements. It will go till the total number of elements. Okay, we need to find out the minimum value of unsorted segment. So we first assume that the first element is the minimum element. So here I'll define min index. Min index equals to I, that is the 0. Okay, and we are going to write one more loop, j loop, that is to widget the remaining elements. Like j loop is, we will widget the remaining elements of unsorted array. Like I'm writing here for j in range, okay, and j we will start from I plus 1, okay, from the second element. Like this is my first element is min element, then I'll start from the next element, and then I'll go till the size minus 1. Okay, and here what I will do, I'll update my minimum index if the element at jth index is lower than it. Okay, so what I will do, I'll compare if array of j is less than, what happened? Okay, array of minimum index means the value at the minimum index is greater than the value at jth index. So we change our minimum index. So min underscore index equals to j. Okay, so from this loop we will find out the minimum element index. After finding this minimum item index of the unsorted region, we will swap this with the first unsorted item. Okay, so outside this loop I can write the comment here, after finding lowest, okay, lowest of unsorted, swap with first unsorted element. Okay, so here I need to write two things, array of I, okay, array of I, I'll put array of minimum index. Okay, and one more thing, array of minimum index, I need to use the temp variable, otherwise I can write in the single line array of I and then array of min index. Okay, and equals to, we will swap like array of I. At the end we will return array. Okay, Getting the things? What I have written here? I'm just finding out the minimum element, index of minimum element, and then we are swapping minimum element with the first unsorted element. Now we write here the driver code. In the driver code, I have to define an array. Or you can say array equals to, I'll take some values. Okay? The same values which I have taken for an example, like 5, 2, 6, 7, 2, 1, 0, 3. Okay? This is my array, and we can print this array as an unsorted list. Print unsorted list is this array. Okay? And now we will call the selection sort method. So we will print after applying this selection sort. So you can say this is the sorted array. Okay? Sorted list is, here I'll call the selection sort method selection underscore sort, and inside this I'm passing this array. Same name, selection underscore sort. This is the program. And you can see the output. Okay, here you can see the output, or this is unsorted list and this is sorted list. So program we have written, now we will analyze its complexity. How does it works and how much time it will take, how much space it will take. Time complexity, you can see here, we are running 2 loops. So in the worst case, okay, worst case is when we have certain elements that are already sorted. So in the worst case, we will run both the loops completely n times. So n into n, this loop is n and inside this is n. So it will take order of n square. Obviously, this is not taking no extra space. So we can say space complexity is order of 1. Okay? And similarly for the best case. In the best case, it will run only for the n times. Getting the things? How this is running the n times? You know that. You should know that. Like we have studied lots of algorithms. Guys, are you getting this thing? Okay. I'm telling you something wrong. Can you please correct me? Actually, it will always, in the worst and best case, it will take order of n square. Okay, somebody has written a question, ma'am, there is an error in the output. Nirmal, what's the error? 3 is not shorted. Let me check it out. Okay, yeah, 3 is not shorted. There is some problem in the code. Yeah, let me correct it. Okay, let me check it out. There is some mistake in the logic. Let me check it out. Just. I have written something wrong. Here I'm defining this and then I'm finding the length and then size minus 1, minimum index is this, and j is I plus 1. Okay, and it is size minus 1. I think this should be size. Okay, and then min index is this is j, and here I need to put one more condition. If I is not equals to min index, then only it will swap. Let me run this again. Expected an indented block. Okay. Yes, this time this is shorted. Actually, I was traversing this less than 1. Like here, I'll write this size minus 1. This time, this 3 is coming in the last. Because I'm not seeing the last element. That's why here, okay, I need to write here the size, till the size. Got it? This loop I don't need to run till the last element because I'm picking the leftmost element. But for this loop I have to traverse the complete elements. This is for unshorted array. Okay? Abhay, Nirmal and Bindu. Got it? Error? Yes, I started the indexing from the 1. And this condition is also will be good, like I is not equals to min index. This will save some time. That's why I have put it this condition also. Because if I is minimum element is equals to I, then it is We don't need to swap this. If I and minimum index is equals, then we don't need to swap. Okay, so this is the selection sort and complexity, order of n square. And this is in place algorithm. Here we don't need the extra space. Enough? And time complexity is, there is two nested loops. So time complexity is order of n square. And now let me tell you one more sorting, that is the heap sort. Okay, basically the important sorting algorithm, we have already covered the 5 algorithm. But you should know what is the heap, what is the heap sort, and how does it works. Okay, so I'll tell you one more concept, that is the heap sort. Okay, heap sort is kind of binary search tree. Okay, this is, you can say this is kind of BST, binary search tree, you know that. We don't need to create a node here. Okay, here we will build a heap. You can say a ordered, balanced binary tree. Like in the binary tree, you know what is the binary tree, okay? And balanced binary tree is, in the balanced binary tree, there is every element having, every node can have 2 childs except the leaf node. Like this should have 2, this should have 2, this should have 2, and this should have 2. Okay, so this is a balanced binary tree. Here every node is having 2 childs. It should have 2 childs except the leaf node. And there is the 2 way, one is the min heap and one is the max heap. Okay, what is the min heap? In the min heap, all the childs having the value less than the root node. Like here is the 10 is the root node, then its child should have the values less than 10. It can be 8, it can be 9. And again its child should have the value less than this, like this can be 1, this can be 2, and this can be 5, this can be 4, something like this. So root always having value greater than its both child. Then you can say this is a min heap. Child don't have any order, like left child can have more value than the right child can have more value than the left child. Okay, it is not necessary that child must be in the some order. Okay, sometimes the value in the left child may be more than the value at the right child, or sometimes the value at the right child may be more. Okay, so what is the heap? Okay, heap and max heap, one thing is remaining. Max heap, in the max heap, sorry, this is a max heap, this is not the min heap, this is the max heap. I have written the wrong. The root having the more value and the root having less value, like it having 8. Okay, then its child should have value greater than the 8, like 10 and 9, something like that. Its child have the value greater than its root. So it can be something 12, it can be 15, something like this. Here 50 and 20. This is called the min heap. Its root having less value. Okay? So heap should follow certain properties. Heap is always a complete binary tree. I can write certain properties for the heap. What is the heap? First property, heap always a complete binary tree. What is the complete binary tree? Which means that all the labels of a tree are fulfilled. There should not be any node which have only one child. Every node except the leaf node should have two childs. Then only you can say a complete binary tree is a heap. So it should complete binary tree. Okay? And second property is heap property. Okay, here the parent node heap can be max heap. I can write heap can be min heap. Either parent having more value than the children, either parent having less value than the children. It should satisfy one of them. Okay, now you got what is the heap. Now we will see heap sort. Okay, so for doing the heap sort, what we can do? First, we will get certain elements. So with the help of the elements, we will create a heap. Okay, so let me open the new file. Understand the heap concept. Okay. Like if we have certain elements like 11, 2, 9, 13, 57, 25, 17, 1, 90, something like this. For these values, first I have to create a heap. So how to create a heap? Initially, I'll pick a value. The first node, I'll create a root node. Then second node, I'll create a leaf node, left and then right, and then again leaf 13, and then 57, okay, then 25, okay, then 17, and then you can say 1, and this is 90. Now you can see, is this satisfying the heap condition? No. So for this, we have to move the nodes. Like we can build either max heap or min heap from this heap. Okay, this is a complete binary tree. So first condition, it is satisfying. Second thing is we need to build a heap from this binary tree. So for creating the heap, like I just want to create the max heap. Okay, for creating the max heap, what I want the element which is maximum will move towards the root node. Okay, so what I can do here, I can go downside, I can check it out. This is 2, then 13 is greater than 2, and then 1 is less than, and this 90 is greater than 13. So this 19 go towards the 13, and then this 90 go towards here and then here. this side also we will check out, like maximum value here the 25 comes and here the 90 comes. From 25 and 90, 90 is maximum. So 90, okay, and then we will see further the minimum elements. So out of these two, in the left side, what is the maximum? 57. So here we will put the 57. And in the left side, right side, you can see we have maximum is 25. Okay, and from the remaining elements, maximum is 13 in the left side of this. So here we will put the 13 and here we will put 11 and then 1 and then 2 and then 3. And this side we are having remaining elements is 9 and 17. So 9 in the left side and 17 in the right side. Now you can say this is a max heap. I have shifted certain shifts. This is the max heap. I have exchanged 90 with the 13, then 2 and then 11. Okay. Now we will heap sort is, we will pick first element. Okay. We put this first element in an array. We remove the root node. So 90 we will remove. Then remaining element is 57, 25. From the remaining elements, we will create a heap. Okay, so from the remaining elements, 90 is replaced by the 57. Okay, and 57 is replaced by the 13. So here the 13. Okay, and in the left side is as it is 25 and then here the 9 and here the 17. And in the left side 13 and then this is the last node we will replace by the last node. So last node, we remove this and we replace by the last node. So here the 13 is going, so 3 we will replace here and here the 2. Sorry. 13 and here I need to put the 13 is going upward and one child is 11 and one child is 3 and then 1 and 2. This is my new heap. Similarly, we will pick the 57. Okay? We do all these operations. After 57, we will pick the 25, then we will pick the 17, then we will pick the 13, 11, 1, like this. $11 and then 3 and then 2 and then 1. Are you getting the things? Can you please confirm me what is the heap? Are you getting what is the heap? What is the max heap? What is the min heap? And then how we can do the sorting in the heap. And we need to write the program for this. Okay? So you know how to build a heap, and then from the heap you can sort the heap. And there is, for creating the binary tree, there is some properties. Like in the binary tree, the node's position, we are following certain formulas. Okay, so in the binary tree formula, we are assuming like the calculating the left child, we are following a formula like 2 into I plus 1. Okay, left child we will calculate by using this formula. This I is index. Like parent node is stored, I is index of parent node. Like parent node is stored at index I, then you can say left child is having index 2 into I plus 1. And right child having indexes 2 into I plus 2. And we are assuming like initially I is 0. Okay, so if I is 0, like root node is at 0th position, then you can say 2 into 0 plus 1. So left child is at 1 and right child is at 2. For this, if this is having index 1 root node, so for its child 2 into 1 plus 1. So you can say 3. And similarly 2 into 1 plus 2, this is 4. These are the index. Okay, we can calculate the index for the left child and right child. So we build a heap first and then we will apply the sorting to the heap. We will define a function for sorting the heap. Okay, so you can try this program by yourself, otherwise I'll tell you a little bit about the logic, how we can write. Let me start writing the code. Okay, heap sort. First we need to construct a heap sort. Like we will pass an array. We are going to have an array. With the help of the array, we create a heap and then we will sort the heap. So inside the heap sort, we first create the heap. Okay, so we define the function for creating the heap. Okay, heap, and here I'm taking the array A, and then inside this array I'm passing the array, and then I can pass the index, length of array. I can calculate the length otherwise. Okay, and the index of current element. So I can write here length and then the current index, I can say I. So current index initially is 0th index, the root node. Okay, first I'll get the one element, like I'm having an array kind of this. And from this array, I have to build a heap. So here I need to process every element. First I need to pick this first element, okay, then second element. So for the first element, I have to define the position in the heap. Okay, and I have to calculate its left child as well as its right child. Okay, so I can say max heap. If I'm defining max heap, then I can say largest equals to I. This is basically I'm initializing the root node. Root. Okay, and for this root, I'll calculate the left child and the right child. Left equals to 2 into I plus 1. Okay, this is left child index. Okay, similarly for the right child index, right equals to 2 into I plus 2. This is for right child. Okay. Now I need to check out the certain conditions, like if my left child is greater than the root, right child is greater than the root, I need to make the root a maximum element. So I'm creating a max heap. Okay. So here I need to write certain conditions. First condition, if left child is existing and it is greater than the root. Left exists and greater than the root. Okay, then we will swap. Like we will put the largest equals to left. Okay, if left is less than length of, okay, left is less than length and this array of largest element is less than array of left. You can say array of left is greater than the root. These are the index. This largest is index for the root node, this is index for the left node, this is index for the right node. So we are checking the left, this left index should be less than the total length of the array. Okay, and the value at root node is less than the left node value, then we can put largest equals to left. Okay. And similar thing we will check for the right node. Like if right node is exist, I need to write same condition. Right exist and greater than root. I have to write the condition. If right is less than the length of array, okay, and array of largest is less than array of right, then we will make largest equals to right. Getting the things? We are creating a heap. Okay, now we write the condition, change the root. If root is needed, we need to swap the root. And recursively we will call the heap. If largest is change, means largest is not equals to this I. If largest is not equals to this I, then we have to change the largest. Means root node we have to change. Either root node is satisfying this condition, left condition or right condition. So we have to swap. So largest is not equals to I. We need to change the root. So you can say array of I, okay, array of I, we will change with the array of largest. Because we got the new value for the largest, new index for the largest. So I can write here array of I and then array of largest equals to, I'll swap, array of largest comma array of I. Are you getting the things? I'm swapping root node either with the left node or with the right node. Like if left node is greater than the root node, then largest is changed. New index of largest is left node. So value at the left node will be put it into the A of I. Otherwise for the right node. And we recursively call this heap. Heap we need to do for the array and length and then largest, whatever the largest value now. So this is for creating the heap. Now we will write a function for sorting a heap. Okay? A simple function we will define for the heap sort. Heap sort. Heap sorting. Okay? So here def heap sort. Okay? And inside this I'm passing my array. I have created a array. Okay? Then n I'm taking the length of the array. Okay? And then I'll build a max heap. How to build a max heap? By calling the heap function. Okay? So here I need to write a loop for every element, for I in range. Okay, reversingly. N by 2. Difference I'm keeping -1. Okay? And I'll go till the -1. Okay, and here heap array I need to pass n and I need to pass I. Okay? And then we will extract the elements for I in range. From the last element we will start. N minus 1, comma 0, comma -1, array of I, array of 0 equals to array of 0, comma array of I. We will swap and then we will apply the heap. And here we need to pass array and then ith index, and this largest initially is root round. Okay? Now we will drive the code. We will start from the topmost for sorting. Okay, so driver code here, I'll pick an array. . You can take the user input, or otherwise I can pick the values that I have already taken. What the values I have taken? 11, comma, 2, comma, 9, comma, 13, comma, 57, comma, 25, comma, 17, comma, 1, comma, 90. Right? This was my array. And then I'll call heap short. And inside the heap short, I'm passing array. And I can print the shorted array. So how can I print the shorted array? Inside the array. So I can write a loop for I in range, okay, and range is length of array, okay, and inside this I can write print array of I. I hope this should work. Let me run the code. Then if you have any doubt, I'll clear it. Yes, this is shorted output 1, 2, 7, 9, 11, 13, 25, 57 and 90. This is the heap short. Just after the class, just revise the heap short and this program, you will get the each and everything. We are doing two things. We are creating the heap and then we are shorting the heap. Recursively, we are calling the things. So you know the recursion. In the last classes, I have told you the recursion also. So now picture should clear about the recursion. Because in the trees and in the shortings, we are using the recursion very frequently. Okay guys, got it? So I think we have covered all the shorting algorithms, and we remaining only the 2-3 topics in this course. Like we have studied all the data structures. One is left out, that is the graph, and one is left out, that is the dynamic programming. So 2 things are remaining. So I'll try to cover 2 things as soon as possible in limited classes so that we can complete this course. Okay guys? I think this is enough for today. Just practice after the class. Bindu is asking, I didn't get any error nor the answer. Bindu, I think you have not printed. Just print array. Print array of I. That's the last thing I have written here. This one. For getting the output. This is the last thing, and I'll scroll up. Don't worry. This is the heap short. Okay. This is the heap short, and above this we have heap function. This to create a heap. Okay. Okay guys, thank you so much, and don't forget to complete your assignments. Last 2 classes assignments is available to our LinkedIn page as well as to our Facebook page, and below the video description, below the video you have to comment the session summary. Okay, thank you so much. We'll see you tomorrow. Yeah, time complexity. I left out one thing is time complexity. That you will try. Or I can say in the heap, time complexity is log of n. Actually, in the it is sorry, n log n. Let me tell you one thing. When we are building a heap, to build a heap, it will take order of n. And to sort the heap, it will take log n. Total, it will take n log n. Like this, complete sorting, including the build heap is order of n, and the sorting is taking log n. So complete sort and build will take n log n. Okay? Okay, guys. Thank you so much.